My name is Graham Haworth. I'm a design director at Haworth Tompkins Architects in London, and I want to talk a little bit about a building we've just completed for the Royal College of Art in Battersea, which is the Dyson Building. And it's a building to take two of the remaining fine art programmes that are currently located in Kensington and move them down to Battersea. And it's basically a building for printmaking and photography. And it's really a building that supports those practices. It's a very technically based building, and what we want to sort of get across in this talk is how we went about making the building, particularly the use of concrete in the building. The location of the building is just behind the main river frontage in Battersea, immediately behind Albion Riverside. And the site forms an entire urban block, and it was originally designed as an RCA competition, which we won in 2007. And it's been designed to be built in three separate phases. And the latest phase of this is the Dyson Building, which is the second of the three. And the building has got a very public-facing frontage onto the Battersea Bridge Road facade. And then behind, in the more interior part of the block, it's much more industrial. And there's a large double-height foyer which has views over the river, which serves as a support space for the lecture theatre behind. There's a 220-seat lecture theatre in there. And the whole building is organised in two parallel blocks, and it's arranged around a central daylit space, a double-height space, which we call the machine hall. And this is going to take a lot of the large printing machines. And in the next building we're building, this is a similar idea carries through, and that's going to house a lot of the kilns and ceramic machines for ceramics and glass. And then the whole building is seen very much as an art factory, a place where art can be produced, and we really like this idea of it being a place of production in terms of its factoriness, but also the fact that it can resonate with sort of the production of art in a sense like Warhol's factory, and then there are all sorts of resonances like factory records. So we quite enjoyed the whole idea of the building being an industrial process-based facility, and the creativity of the students comes into that. So it's very much a building that supports other activities. And part of that was to try and create a lot of horizontal drift and visual transparency through the building. So you get these very long views through. So you can see other people working. It may be part of your discipline. You may just be a member of the public wandering through. But the idea is to try and get in a lot of visual complexity and visual connectivity through. This illustration shows the makeup of the building, really, with the four-storey workshop block on the right, and the double height machine hall in the centre. And in the next phase, this central portion gets extruded out to form the whole development. We followed the factory aesthetic through into the making of the building, so we've used quite simple materials in a very direct way. You can just see the reflections of the sawtooth roof of the painting school opposite, which was the first phase that we completed. And we used the painting school to road test really a lot of the ideas that we transferred into the second phase, and they will also be transferred into the third phase. So on the left is a cross-section of the Sackler building with the double-height painting studios with smaller studios looking down. And we also prototyped these north-lit sawtooth roof forms as well, which get very good north light into the spaces to provide constant light for working. And again, those are something we're transferring over into the new building. We tried to look at precedents that captured that idea of a creative work and making going on in an industrial environment. And I've always liked this building in Germany by Uwe Kiessler. It was finished in the mid-80s, and it's a technical support facility for Erco lighting. And he came up with this phrase that he wanted the building to be an overall for engineers. So it was a piece of clothing, an artifact that helped them in their work. So it was very useful. It had pockets, zips, and it protected you when you were doing the machinery. So we thought that was a really good metaphor. And then more recently, we're very interested in provisionality of space and things that change over time. And Stephen Holl's building at Iowa, he uses the expression a hybrid instrument. So it's not a specific architectural environment, it's not pinned down, it's very fluid, very open, and again you get quite large distance views through from one space to another. In terms of the use of concrete, we've always had, as a practice, a very strong interest in concrete, and my personal sort of love of it goes back to being a student, really. And I want to show 3 slides by a Japanese architect called Kazuo Shinohara, who had a big influence on a lot of the younger generation of Japanese architects like Toyo Ito and Hasegawa, in the fact that he was trying to introduce social issues and local vernacular, Japanese vernacular issues back into architecture as a sort of reaction to metabolism and a lot of the sort of global ideas that Japanese architects were interested in the 60s. He reacted against that. And he used concrete in a very elemental and organic way. And this is one of his early buildings. It's a house. And he's exposed the concrete structure within. It's almost in a very, almost in a primordial way, really. It's very, it feels very primitive, almost that it's a natural material from the earth. And it has a sort of poetry to it. And we like that aspect of concrete. So it's almost, along with stone, it's probably the only material that has that sort of really strong poetic quality to it. He used the concrete in a much more fluid way. He was very interested in the idea of form following function, and he wanted one material to do several jobs. So concrete's perfect for that. It's the perfect modernist material. In fact, you can go from a wall to a column to a floor seamlessly, and you don't have to clad it in anything. It's not like steel or timber where you're building the carcass and then lining it. It's a material that does everything, and it's finished. In his later work, he started to get a little bit more crude, I think, in the way he used concrete, and I think this is kind of interesting in the way that we've used it in the Dyson building. We're using it as an elemental material that forms the primary surfaces, and against that we've placed more industrial artifacts such as gantries, roof lights, ductwork, all the sort of more temporal things that will probably change over time. They're set against the permanency of the concrete. So in our top floor daylit studios for photography, for example, we're using the frame, exposing the concrete of that to set the basic armature of the space, but then we're playing other things against it. In the building, we've used concrete in two primary ways. One is for the main structure of the building and the main circulation spaces and cores, and for that we've used in-situ concrete. And then the other use of concrete is through precast elements for the main facade material facing the main street frontage. I'm going to talk a little bit about the in-situ use first. And particularly, rather than talk about the whole building, I'm just going to focus on the main foyer space, which is a triple height space which tries to express this idea of visual transparency and movement through the building in this sort of hybrid way. You enter the building directly on the axis of the main machine hall, so you've got a very strong view into the process spaces, and then there's a very sculptural staircase which takes you off and up to the foyer spaces of the lecture theatre, and then even further up into other support spaces. And that first floor foyer has a very strong connection with the river. And we've used concrete in its plastic form to create this very dynamic and sinuous staircase, which almost sort of crystallizes a metaphor of movement through the building. When you get up to the upper foyer, again we've exposed all the concrete surfaces within the space, and we're setting other lighter elements against it, whether it's light fittings and ductwork or display walls. They're inserted within the sort of carcass of the building. We've also used a polished concrete floor throughout most of the public spaces, and in the studio spaces we've just used an in-situ concrete screed, which is quite sort of tough in the butt. And against the earthiness of the concrete, other elements are set, whether it's quite elaborate sliding door mechanisms or whether it's the art that the students are making within the building. And what's fascinating about concrete to us is that it's completely plastic. It's almost a liquid, like liquid stone in a way. And What is really obvious to state about it is to actually make something out of it, you have to create a mould in the first instance. And I've always been interested in the way Rachel White readers cast negative space in existing moulds, be them existing buildings or existing staircases. And in a way, her job's slightly easier because the mould already exists and you can walk around it, whereas we have to sort of get our head around making a mould to then a negative mould to cast a positive object, which then creates the space. So it's sort of 2 steps removed from what she's doing in a way. And the only way we can do that is to make a lot of models and 3-dimensional representations of the space before we can commit to the design. And as you see here, there are some very complex geometrical collisions and interfaces between the different surfaces within the main foyer space. And to try and secure the quality of that through a build process, it's necessary for us to actually physically draw every component and work out how our mould goes together and what the imprint of that mould is going to have, the effect that mould is going to have on the surfaces that are cast from it. So that really necessitates drawing every condition, drawing every joint line, and setting out every bolt connection that holds the formwork together. And that applies to the soffit scape as well, where you have to understand that the soffit is also cast from the same process, and that needs an equal level of care and dexterity if you're going to be successful with it. Prior to letting the contract, we interviewed various contractors and made sure that their primary subcontractors, in this case it was Waits, were the main contractor, and a company called Turing Mannion were the subcontractor. We needed to ensure that they understood the quality we were getting, that they priced it appropriately when they were tendering. And we went to visit a couple of buildings with them to talk, literally to inspect other people's work and work that they'd done before to set the quality benchmark. And then when they got into their process of working drawings, they provided us with a whole series of shop drawings which illustrated the formwork, the way that worked, where the mould joints and panel joints occurred on each particular wall or surface. And a lot of it was quite iterative. We would put forward a proposal for where our ideal symmetrical arrangement of bolts and panels would be, and then they would come back and say that doesn't quite work, we can't do it like that, it's not efficient, there's a lot of wastage, and we would move through the whole process together. So the communication with the maker of the concrete and us as designers was really critical, and that dialogue was really important to establish. When we got onto site, we then tested a series of prototypes, full-scale walls, columns and soffits to make sure that the quality was coming through. We used a timber former, a plywood former, with a special surface coating. We were getting probably 3 or 4 repeat uses of these moulds. And we tried to establish benchmarks for the quality of the surface, the level of sort of pot marks and blowholes that you get, and also the treatment of the main bolt holes. And the mix we used here was a Portland cement with a blast furnace slag component of about 40%, which gives the concrete its creaminess and its whiteness. And then the other 2 components in that are obviously the sand and the aggregate. Those were very, very carefully specified within the contract documents. And as the building evolved, we began to see that this negative mould that we'd made in the formwork was then turning into positive elements which were creating the overall space. And we really enjoyed a lot of the way that these junctions between columns and surfaces came about. And here, for example, we tried to articulate the actual movement of the staircase with the way that it was structurally supported, so there's a distinction between the column and the actual wall surface. And also we wanted to try and avoid kicker joints between the staircase and the walls, so we cast the walls first. That's why you get this sort of detail line running underneath the soffit of the upper flights, and how we've managed to achieve a very monolithic feel to the stair as you're looking down onto it. We managed to achieve a really high standard of quality throughout the installation, and it does have this sort of very elemental, abstract, sculptural qualities which we were looking for in the design. And on the top of the staircase we wanted to get a very simple profile detail. Often you knock the tops off concrete to make sure it doesn't get damaged, but we inserted a little moulding into the formwork, so when it was pulled away We had a very nice ridge detail which protected the main wall, but gave the concrete a sort of subtle detail at the top, which was actually quite sophisticated, and it's really just achieved by a 10 by 5 mil batten applied to the plywood. So while the main foyer was being built, the rest of the building was in construction, and we used concrete throughout, basically, for all the main service cores, for all the structural floors. The advantage is that it's finished once it's cast. It doesn't need to be fireproof or fire rated in any way. And we enjoyed it on occasion using lighter weight materials to set against the heaviness of the concrete. So at the top, on the main photographic studios, we're using steel structure, and the central machine hall has also got steel truss roof. So the idea of something quite relatively lightweight being bolted onto something quite heavy is again something that we really were exploring in the design. And this whole idea of making the building in the same way as the use of the building is for making things, we were interested in making the building and expressing how it went together. And throughout, even through the secondary spaces, we were achieving a very high standard of quality throughout. The second element of the use of concrete in the building is the use of the precast on the outside. It's almost like a terrazzo. It's a highly polished black aggregate concrete, basalt aggregate concrete, and it's again it's a bespoke product. It's handmade in Belgium, a company called Docomo, and you can see the guy in the illustrations here hand polishing part of the profile. We selected a series of basalt aggregate particles, and we had a series of test samples made, which at tender we did so that we could go to anybody. But in the end, it was only this company that could actually replicate the mix of the samples they gave us. They have a sort of secret recipe, which nobody else was able to replicate, and they have some little shiny elements that go into the mix, which again we don't know what they are, but they just have a way of making it. So the main contract was let to Docomo in the end, primarily because they were the only people that could to get the standards and the qualities we were looking at. We were almost trying to get the quality of polished granite in a way through the concrete. And not all of the concrete is polished by hand. It was just the edges that are polished. They have a flatbed polishing machine, so you can get high levels of shine and clarity to the columns. We went over to the factory to inspect the main batch production for quality, and we then, in parallel with that, worked out how we might put the concrete panels into a cladding system. So we worked with our cladding consultant, Harry Montresor, to devise a preliminary detail about how the concrete would be assembled within the curtain walling, which was then developed by GIG, the subcontractor, into a working assembly. So we took the panels from Docomo, and then we built a whole series of test rig prototypes in Austria with GIG. And one of the most interesting details about it is how we closed down the cavity between the concrete and the backing substrate, and we invented this little flipper gasket. Originally, Harry proposed some form of squashable stuff, which nobody quite knew what it was, and through the technical development with GIG, we went for almost like one of those little pinball flippers that is a continuous neoprene seal that runs all the way around the panels, and it acts under tension. So once the panels are pressed into place, the gasket forms a waterproof seal. And that's how it looks in main elevation. There's a little bit of funny junction at the centre where you had to make a special interlocking piece to deal with that. And that's how the arrangement of the panels go in plan. They're supported off the steel substrate, and this is a concrete to concrete junction, so it's a sort of V junction between the two. And the flipper gaskets, you can just see there's one just attached to the back of the left-hand panel, formed of weathered steel. And where we have a concrete on concrete detail, we pin the two concrete panels together. This shows where the aluminium detail and the concrete come together, and we wanted an almost zero tolerance detail. We wanted the aluminium to be flush with the polished concrete, and to achieve that we had to build in very rigorous site tolerances, but it went together beautifully in the end. And we tested this out on the test rig in Austria at GIG's factory so we could see how all the details met together, how the alignment worked. And then we could also look at testing the water penetration factors on the panel, so the whole thing was tested on a wet rig, spray rig as well. And that meant that when we actually built the building, it went together remarkably smoothly, and it's created a very smooth facade. We've got a very minimal detail at the parapet. It tips backwards, so you can't actually see it from the street. So the concrete looks like it's forming the edge. And then at the base, we've got a large stainless steel channel which just sets the concrete up above the gallery space and the foyer space below. I mean, our use of the two different types of concrete in the building has been very deliberate, and it's been influenced really by, I suppose, our desire to create a very sculptural interior, which not only is it beautiful, but also it's very robust and can be knocked about by students. So that's the use of the in-situ concrete. I think in the UK, there's been a tradition of associating in-situ concrete or raw concrete on the exterior of buildings with brutalism, and buildings are not particularly well loved by the public. And I think that has influenced our thinking about the choice of material for the outside. So rather than use the same cementitious material for the facades, we deliberately chose to use a more sophisticated, more finished product, still concrete, but bordering more towards terrazzo. So we used something that had an inherent colour, it had a high sheen and high level of finish. And I think that has been influenced by how concrete weathers over time, particularly in this country. And I'm not sure on this street frontage whether raw concrete would have been the right one to use, because I think we needed to communicate a different quality of the building. It had to really communicate the more public-facing end of the Royal College of Art, and the more corporate's the wrong word, but it had to have a higher level of finish. The building has just been recently completed in September, and it opens to the students in October for the first academic term. And we had an opening ceremony the other day, which was a really good moment to see the building full of people and full of life. And there was a special opening ceremony which James Dyson attended, where he printed off an original print by Peter Blake on the etching press. And it was a really nice moment to just mark the end of this next phase of development for the college. And we're just out to tender at the moment, and due to start on site in January 2013 with the final phase of this whole project, which is an extension of the central workshop block to form studios for ceramics and glass and what's known as GSM&J, which is goldsmiths, metalwork and jewellery, together with some sort of non-denominational studio spaces for other fine art practices. And that should be up and running by September 2014. One of the really nice things about the project for us was that it was a very personal project for the college. It was a very big move for them to develop a new site in Battersea. They wanted the building to represent their ethics, their ethos, their ambitions, and actually reflect the Royal College. So it needed to have the characteristics that the existing college has, and that made it a really personal project. And it was also, part of that was also, it was a very bespoke project. The users that are going in it they've all got very specific disciplines, and that lent itself to a very bespoke response in the architecture. Whilst it had to be flexible, it had to be a bespoke response to the equipment systems and the teaching methods that the academics use. And it's quite rare to get that level of bespoke design and end-user design. Everything these days is tending towards the generic and the non-specific, whereas this is very specific. And that translated itself into the use of the materials, the choice of main contractor through weights, and also the choice of the subcontractors. We had two extraordinary subcontractors in Turin Mannion doing the in-situ and GIG doing the exterior facades. And I think that was almost a statement from the college that they wanted to benchmark the building at a certain level that reflected their quality of design and their aspirations too.